This video is on graphing quadratic's intercept form. Now let's start with one in standard form. Now we're going to go pretty fast, okay guys? So here we go. What's the first step? We always make a table, right? We always make a table. And of course we don't want to pick any number. We want to pick the right number. So we use negative b over 2a to find the intercept, correct? So here we go, negative b over 2a. B, you notice, is 10. And a, you notice, is 1. Again, the 10 is my b. And the number or coefficient of x squared is negative 1. And so a is always a coefficient of x squared, so that's negative 1, and b is a coefficient of x, 10. And if we do our math, you notice we'll get negative 10 over negative 2, which is positive 5. And that is where the vertex is, right? That's the middle of my table. And then, of course, I just count in order: 4, 3, 6, 7. So notice I have them all in order: 3, 4, 5, 6, 7. And now I'm ready to use symmetry and graph these points. So here we go. I'm going to again use synthetic to help me out with my calculations here. Negative 1, 10, negative 23. And I'm going to plug in 3. So I bring down a negative 1. I multiply negative 3. That's a 7. I multiply again, 21 minus 23 is negative 2. So not only do I know that's negative 2, but I know 7 is negative 2 because of symmetry. Okay, because of lack of space, guys, I'm going to go ahead and clean this up. And I'll just do that as I go through the problems, okay? So let's see here. Let's try 4, of course. So we start out with our ABCs, negative 1, 10, negative 23. Plugging in 4, I bring down the negative 1. When I multiply there, negative 4, that leaves me 6. When I multiply there, 24 minus 23 is 1. So 4 is 1, and 6 is 1 again because of symmetry. Pause the video if you need to. Okay, and then finally I've got to do 5. So I'm going to again copy down my coefficients and my constant, my ABC values. I'm going to start with 5. I'm going to bring down my negative 1. When I multiply, that's negative 5. 10 minus 5 is 5. When I multiply 5 times 5, 25. Minus 23 is 2. So now, guys, I'm ready to graph, right? I'll go 3, negative 2. 4, positive 1. 5, positive 2. Remember, that's my vertex. 6, positive 1. 7, negative 2. And right here is my parabola, right? So again, notice when I go to the next set of problems in graphing, I'm going to do similar things. So pause the video before I move on to the next example. Okay, so guys, what's the first thing I'm going to do again? That's right, I'm going to make a table, right? Now, what's different about intercept form is I'm not going to do what we did before as far as using synthetic, all right? Intercept form actually turns out to be easier once you get used to it. What do I do first is I look right here and I think, what makes that 0? Well, isn't 4 minus 4 0? And of course right there, what makes that 0? 1 minus 1 is 0. So I already know 2 points, the x-intercepts of my equation, you see? Now I'm just going to put them in a table, guys, and I'm just going to count in order again. I'm going to do 1, 2, 3, 4. I left a space up here, so I might as well go ahead and do 0, right? And let's go ahead and add another 1, 5 at the other end. And let's see how this works. But again, notice how I filled in the table. all I did was use my intercepts, which I found up here. And we already know those two values, by the way. 1 is going to give me 0, and 4 is going to give me 0. Okay, so let's continue on. Let's plug in 0, for instance. Okay, let's plug in 0. And won't we get 3 times 0 minus 4 times 0 minus 1, 3 times negative 4, 0 minus 4 is negative 4, 0 minus 1 is negative 1. And so that's negative 12 times negative 1, so that's positive 12. Now that number is actually too big to graph, isn't it? But 5 will also be positive 12 because of symmetry. Now let's go on to the value 2 right there in my table. 3 times 2 minus 4 times 2 minus 1. 3 times negative 2. 2 minus 4 is negative 2. 2 minus 1 is 1. Hey, that's negative 6. And so is negative 3. Now notice I ran out of points, guys. And the reason why is because the vertex, you see, is between 2 and 3. So what's the value in the middle of 2 and 3? Well, that would be 2.5, wouldn't it? 2.5. Okay, so I'm actually going to do it one more time with 2.5. So here I go. 3 times 2.5 minus 4 times 2.5 minus 1. 3 times 2.5 minus 4 is negative 1.5 times 2.5 minus 1 is 1.5. I get 3 times, now this times together, guys, is negative 2.25. So times by 3, I end up with negative 6.75. Oops, sorry about that. 6.75. Getting too close to my little arrow there. So guys, what I ended up doing is having to find the vertex, which is always in the middle between those points there. Okay, and we'll have to talk more about it in class on basically why that works that way. But anyways, let's do our graph. We can't obviously graph 0, 12, but I'm going to go ahead and plot 1, 0. Let me try that again. I'm going to go ahead and plot 1, 0 right there, right? I'm going to plot 0, negative 6, which is right there. I'm going to go ahead and plot let's see here. Oh, I'm sorry, it wasn't 0, negative 6. Boy, I'm really messing up here. Sorry about that. That was actually 2, negative 6, right? And our vertex was at 2.5, negative 6.75. So somewhere about right there, right? And then we had, of course, 3, negative 6 right there. And 4, 0. So as you can see here, ladies and gentlemen, is my parabola. Okay, and that's basically how it's done. Now let's just try one more, and hopefully we won't have as much difficulty. So here we go, as you probably already saw it. So what am I going to do to graph this again? I'm going to make a table, right? How do I find what points to put in for x? I look over here and I ask myself, doesn't negative 6 plus 6 make a 0? And I look right here and I go, what plus 3 makes a 0? Negative 3. So those are 2 points already in my table, guys. And I'm just going to put in my table and count in order. So I'm just going to go negative 6, negative 5, negative 4, negative 3. Okay. Now, I could add a couple more points, but what I notice already again is I have an even amount of numbers. So let me space them out a little bit more here. Let me start over here. So I'm going to put in negative 6, negative 5. All right. And then I'm going to put in negative 4, negative 3. And I know that the vertex is at negative 4.5. Now, another way you can figure that out, by the way, guys, is what happens if I average negative 6 and negative 3. Isn't that negative 9 over 2, which is negative 4.5? Because the vertex, you see, will always be between your two roots. Okay? We'll have to discuss that, like I said before, in class. But let's finish up our graph here. So I'm going to first plug in negative 6. Oh, wait a minute. We already know negative 6 gives us 0, right? Just to make sure you understand, I would have negative times negative 6 plus 6 times negative 6 plus 3, right? And negative 6 plus 6 is 0, so anything times it's going to be 0, right? And the same thing is going to happen over here when I plug in the negative 3. So we already have 2 points again, the zeros. Let's start with negative 5 next. Negative of negative 5 plus 6 times negative 5 plus 3. Negative of 1, 6 minus 5 is 1. And negative 2, negative 5 plus 3 is negative 2. And notice I get positive 2. And negative 4 is going to be positive 2 again because of symmetry. Again, isn't negative 1 times negative 2 positive 2? So the only thing left is negative 4.5. So pause the video if you need to, guys. I'm going to do some erasing here. Okay, I'm just cleaning this up here a little bit. So all I need now is a vertex, right? So I'm just going to take negative of negative 4.5 plus 6 times negative 4.5 plus 3. 4.5 plus 3 there. And let's see here. I get negative of 1.5. 6 minus 4.5. It's 1.5. And negative 4.5 plus 3. Well, that looks a little messy again, doesn't it? I think I'm a little under the weather again. Negative 4.5 plus 3 is negative 1.5. So again, we get the negative 1.5 times a negative 1.5. Well, that's 2.25. All right? And we're ready to graph. So we're going to go to negative 6, 0. We're going to go to negative 5, 2. We're going to go to negative 4.5, 2.25. That's a little bit too high, but close enough for my little graph here. Negative 4, 2 is right there. And negative 3, 0 is right there. So if you notice, guys, here basically is our nice graph sketch of this parabola. By the way, why is the parabola opening down? Notice how it is opening down this way, right? That's right, because of the negative. Don't forget, guys, the coefficient in front of the quadratic tells you whether it's going up or down. Whereas, if you notice, on this one, because of the positive 3 right there in front, that's why it opens up. But anyways, guys, I hope you grinded through this video a little bit longer than usual. But we'll break it down in class and talk about some of the specifics, okay? Until next time, bye.